Welcome back. In our next several lessons, we're going to be working on a model. The files are located in the exercise folder of this course. We're going to be building a handheld video game with a fairly complex surface to model. We'll begin with the interior, the circuit board, LCD monitor, and button sensors. Let's start with a sketch on the top plane. Activate the rectangle tool. Apply dimensions. This dimension will be 53 millimeters. OK. And this dimension 31 millimeters. OK. Now a construction line. Corner to corner. Right-click and select. Let's shift-select the construction line and the origin point and add a midpoint relation. OK, and let's exit the sketch. Features tab, Extrude. We're going to create a 6 millimeter extrusion. Blind. And click OK. Of course, this isn't actually the LCD display itself, it's just a representation of the display. In other words, the top face represents the location of the display itself, and the box represents the height, depth, and width of the display. In real-world design, this is often how you'll do something. You'll be working with a prefabricated part for, let's say, this display, and then all you'll need is the dimensions of the display so that you can fit it properly within the rest of your model. What we'll actually be designing are the top and bottom covers of the video game, both exterior and interior. Let's move on and insert another sketch. Let's take a normal 2 view now. And let's create another rectangle. Let's apply dimensions. 72 millimeters here. OK. By 83 millimeters here. OK. The distance from this line to the origin point, let's do that next, 22 millimeters. OK. Now activate the point tool. Let's place our point somewhere here. Shift-select the origin point and this point and add a vertical relation. OK, and exit the sketch. Isometric view. We're on the Features tab. Let's activate the Extruded Boss tool. Let's extrude 0.85 millimeters in the negative Y direction. I'm doing it this way so that I can use the top plane as my cutting tool later on. OK. What's happened here is that I've got my PC board and my LCD display. As we talked about a moment ago, the top face represents the actual display. We know how far above the board the display will be when it's installed. Let's go on. We'll chamfer the bottom corners now. Chamfer tool. Let's clear the selection window and select this corner to chamfer, as well as this corner. The chamfer will be 4 millimeters at 45 degrees. Now we're going to create the sensors for the buttons. Normal 2. Construction line. Right-click, select. Now I'm going to drop 5 circles here. And right-click and select. Now let's shift-select the circles and add an equal relation. Let's apply some dimensions now. The overall distance will be 50 millimeters. The distance between the circles will be 12.5 millimeters. OK. OK. The circle diameter will be 4 millimeters. Now I'm going to use a 3-point arc and drop it somewhere here. Right-click and select. Let's use the circle tool to create 3 more sensors. Last circle, right-click and select. Let's shift-select these circles and add an equal relation. Now let's add some dimensions. We'll start with the overall distance. That'll be 40 millimeters. OK. And the distance between circles will be 14.5 millimeters. Okay. This distance, let's make 16 millimeters. Lastly, I'll place an elliptical sensor. And let's dimension it. 20 for the major axis by 7 for the minor axis. Let's position it 6 millimeters from the bottom edge. Okay, now we're going to create a construction line from this point to this point. Right-click, select. Let's add a coincident relation between the line and our circle. And now let's add a vertical relation to the line. Let's shift-select the line and the origin point. Also add a vertical relation. And let's shift-select these 2 points here, 1 and 2, and add a horizontal relation. Let's add a dimension now. 27 millimeters. OK. Right-click and select. Now select this point and this line and add a coincident relation. OK. Now I'm going to shift-select this point and this point, add a horizontal relation. OK. Lastly, let's dimension this circle. We'll give it a 4 millimeter diameter. Our sketch is fully defined. Let's exit. Take an isometric view. Extruded boss base. We want a depth of 0.5 millimeters in the positive Y direction. OK. Oops, the sketch has both open and closed contours. Let's fix this problem. We'll edit our sketch. I need to convert this line to construction geometry. Exit the sketch, back to the Extrude tool. Let's select Sketch 3. The preview now gives us a representation of the sensor's position, shape, and distance from the circuit board. It's time to save our file. In the exercise files for this course, I've created a directory called Pocket Game. All of the part files for this project will be located there. Let's call this part the circuit board. And click Save. Now I'm going to activate the Split command. Insert, Features, Split. For the Split tool, I'm going to use the top plane. Then I click Cut Part. As a result, I end up with 11 separate bodies. I'm going to save these as separate files. To do so, just double-click on a flag. The Save As dialog window will open. The first part I selected was the LCD display, so I'm going to name it appropriately. I'll call it LCD. And click Save. Body number 2 is the PC board. Let's double-click on its flag and call it PC board. And click Save. I'm going to pause the video while I save the rest of the files. I don't want to bore you with this process. I'll see you in just a minute. All right, welcome back. I've renamed all of my solid bodies appropriately. Let's click OK to exit the Split Property Manager. Now let's expand the Solid Bodies folder. As indicated, we've got 11 solid bodies in the folder. The results of our split are located in the Solid Bodies folder. Solidworks saved all of these to our project folder, as you see here. All 11 parts are currently open and are available under the window menu. Let's go back to the circuit board. Now let's convert our part to an assembly. Right-click on Split 1 and select Create Assembly. Let's browse. We'll call this assembly Circuit Board. And click Save. OK. Solidworks prompts us to see if we want to rebuild now. Yes, we do. And we've successfully created an assembly. To edit the parts of the assembly, You can right-click on any of the parts either in the design tree or in the graphic workspace, and then select Edit Part. Click Accept in the confirmation corner to exit editing part mode. And this concludes our lesson on building the circuit board.